What if I told you the biggest battery breakthrough of this decade didn't come from Silicon Valley, not from Tesla, not from Europe, and not even from Donut Lab? It came from China. A 400 watt-hours per kilogram solid-state battery, not a concept, not a lab rumor, but a validated prototype, has just entered the spotlight. And if the claims hold up, this single battery could rewrite the EV race, humiliate existing solid-state players, and possibly end the hype era around Donut Lab's so-called unbeatable design. For years, Donut Lab positioned itself as the future of energy storage, radical architecture, insane power density, and bold promises. With now a quiet, methodical, almost boring announcement from China might have done what no flashy startup could. It may have won the battery war, but before we crown a winner, let's slow down, because the real story here isn't hype. It's chemistry, physics, geopolitics, and manufacturing reality. And by the end of this video, you'll understand why 400 watt-hours per kilogram is a psychological breaking point, what China actually achieved and what it didn't, why Donut Lab may not be dead, but cornered, and why this moment feels eerily similar to what happened to solar panels a decade ago. This is not just about batteries. This is about who controls the future of energy. WHY 400 Wh per kilogram is a big deal. No hype, just math. Let's start with the number everyone is screaming about. 400 Wh/kgto. Most people, it sounds abstract, but in battery terms it's borderline insane. Put it into perspective. Typical lithium-ion EV batteries today, 250 to 280 watt-hours per kilogram cell level. Tesla's best 4,680 projections, 300 watt-hours per kilogram optimistic, not mass-proven. Most solid-state promises. Toyota QuantumScape, 350 watt-hours per kilogram. Eventually crossing 400 watt-hours per kilogram doesn't just improve range, it changes vehicle architecture. At this level, EVs can hit 900 to 1,000 kilometers range without becoming heavier aircraft. Electrification becomes technically plausible. Grid storage shrinks dramatically in size. Thermal management complexity drops. Structural batteries finally make sense. This is the threshold where battery constraints stop dominating design. And that's why every company on Earth has been chasing it. But here's the catch. Getting to 400 watt-hours per kilogram isn't about one breakthrough. It's about solving 5 impossible problems at the same time. Energy density, cycle life, safety, manufacturability. Cause most companies solve 1. China just claims to have solved 4. That's what shocked the industry. What China actually announced. No misleading headlines. Let's clear up the misinformation first. China did not announce a magic battery that's already in millions of cars. What they announced was a lithium metal battery verified at approximately 400 watt-hours per kilogram at cell level, past nail penetration, thermic, and overcharge tests, achieved 800 cycles with 80% capacity retention. Designed for mass manufacturing compatibility. And this last point is the most important, because history is full of amazing batteries that died in factories. Who is behind it? A consortium involving a major Chinese battery manufacturer, a state-backed materials institute, multiple EV OEM partners unnamed. But obvious, this wasn't a startup pitch deck. It was a manufacturing announcement. That alone puts Donut Lab on the defensive. Solid state, real vs MARKDNG. Let's talk about solid-state batteries honestly. Solid state doesn't mean perfect safety, infinite life, zero deg. Simply means the liquid electrolyte is replaced with a solid or semi-solid medium, and that creates massive advantages. No flammable liquid, higher voltage stability, lithium metal anodes become possible, smaller separators, higher packing density, but it also introduces brutal problems. Interface resistance, cracking during charge cycles, dendrite formation, manufacturing yield nightmares. Most Western companies solve this by using thick solid layers, lowering current density, accepting slow charging. China went the opposite way. The Chinese approach, boring, brutal. EFFECTFIC didn't invent new physics. They optimized the hell out of known chemistry. Their approach, hybrid solid polymer electrolyte, ultra-thin ceramic, reinforcement layers, lithium metal, anode with controlled deposition, aggressive stack pressure control, existing roll-to-roll production, compatibility. In simple terms, they didn't chase perfection. They chased scale. This is exactly what China did with solar panels, LFP batteries, power electronics, and every time the West laughed, until prices collapsed. Where Donut Lab enters the story now. Let's talk about Donut Lab. Donut Lab's core promise was architecture, not chemistry. Motor-integrated wheels, distributed energy, storage, structural efficiency, extreme power density, and, to be fair, their design is genuinely innovative. But here's the problem. Donut Lab's battery roadmap relied on high power density cells, lower energy density, complex cooling, premium manufacturing. China's 400 watt-hours per kilogram cell doesn't need exotic integration. It simply delivers more energy in less space with less complexity. That's dangerous because it means OEMs don't need to redesign vehicles to get massive gains. They can just swap suppliers. Did China destroy Donut Lab? Short answer, no. Long answer, they changed the battlefield. Donut Lab still wins in Power 2.8 at the system level: wheel motor integration, performance focused applications, robotics, drones, specialty EVs, but they lose momentum in mass market EVs, commercial fleets, cost sensitive platforms, government backed adoption on. That's where volume lives. China doesn't need Donut Lab to fail. They just need them to become irrelevant at scale. The real weapon. May and UFA C2URNG. This is where the story becomes uncomfortable. China didn't just build a battery. They built the materials, supply chain, the refining capacity, the equipment, the ecosystem, the government incentives, the OEM integration pipeline. Western companies still treat manufacturing as an afterthought. China treats it as the main product. That's why this announcement scared people. What this means for Tesla and Toyota and the WS to Tesla still leads in software and system integration. Battery innovation now under pressure. 4,680 suddenly looks considered. Toyota years ahead in solid state research, years behind in execution speed. Excellent science, weak industrial coordination. This isn't a technology gap anymore, it's a strategy gap. The safety question, the quiet achievement. One of the most overlooked parts of the announcement. Thermal stability at high energy density. 400 Wh per kilogram usually means runaway risk, catastrophic failure, but testing showed no ignition, no explosion, controlled failure mode. That alone is huge, because regulators care more about safety than range. What happens next? Realistic timeline. Let's be realistic. You won't see this battery tomorrow. Expected timeline: 2026. Pilot production 2027. Limited EV deployment 2028 to 2029. Mass adoption. But that's enough, because once manufacturing starts, prices fall fast, and once prices fall, everyone else panics. This is not the end. I tease the SHIFT. China didn't win forever, but they just forced everyone else to react, reset expectations, raise the minimum standard. Donut Lab isn't dead. Tesla isn't finished. The West isn't doomed. But the era of battery hype without scale is officially over. From now on, the winner won't be the boldest promise, the flashiest prototype, the loudest CO8. Will be the company that can make millions of boring, reliable, insanely dense batteries at a price no one can beat. And right now, China is terrifyingly good at that.